Hi, in this lesson I want to talk about logarithmic functions. Now, logarithms are still under the topic of inverse functions. In the previous video, we did an example of finding the inverse of a linear function. But how do we find the inverse of a logarithmic function? Say y is equals to 2 to the power of x. If we follow the same steps, we swap x and y, we get x is equals to 2 to the power of y. But then the second step, how do we make y subject to the formula? So this is where logarithms come in. Normally we have x is equals to the base to the power of some variable y. Then, in order to convert this into its logarithmic format, we say that y is equal to the log of whatever the base is, x. So in this case, we're going to have y is equal to log of 2x, like that. So that is logarithmic functions, and if we were to visualize this, we would get something like let's rather use this. So visualizing logarithmic functions, we're able to see just how they reflect, and we're able to see also just the nature of these types of functions, which are inverse functions. So this is a normal, maybe not so normal actually. This is a normal exponential function, and to find its inverse, we've already done the process. All that is left is to map what the function would look like. Now the function would look something like this, and as you can see, this is sort of a reflection about the line y is equal to x. So like that, y is equal to x. We can see that these two are sort of mirror images of each other. And the thing is, with inverse functions, as much as we swap x and y, the domain and the range also swap. So if we were to describe the domain and range of our original function, we would say that the domain, which is all the possible x values, is that x can be any value it wants to be. So x has no restrictions. X is an element of all real numbers, right? Then the range would be y is an element of all real numbers, but y has to be greater than 0, because as we can see, our function has an asymptote at the x-axis. So the inverse of this function now would have the following properties. The domain would be all the possible x values. Over here we can see that our function is not defined in the negative region, therefore its domain is x is an element of all real numbers, but x has to be greater than 0. Then its range, as you can imagine, will just be what the domain is over here. So we can say y is an element of all real numbers, and there is no restriction because y can literally be any value on this on our function. And how do we represent this? If this is f of x, then this will be f to the power of minus 1 x, to show that the function has been inversed. It is still f, but it has been inversed. Another example of how the inversing works is if this coordinate over here is 0 as to 1, then this one over here will have x and y swapped to give 1 as to 0. And this will be similar for any 2 points that are on similar points on the functions. So that is that on inverse functions and logarithmic functions.